Hello, welcome to EA Technology's latest webinar on the future of partial discharge detection. Joined today by myself, Gareth Devine. So I currently head up the development engineering, specifically the UltraTev product aspect of EA Technology. I spoke to you on the two previous webinars in this series. I'm also joined by my colleague.
Hi, good afternoon. My name is Phil Smethurst. I'm a business development / key account manager with EA Technology presently. And before we get into the webinar proper, if I may, I'm just going to pop us over onto a little bit of background on EA Technology that's relevant. So I'll just pass on the next slide, bear with me. So back in the 1960s, when the business or the company was established as an entity as the UK's Electricity Council Research Centre, essentially helping the network operators of the time, and over the years developed some good projects with respect to the electricity networks and so on. And come the 1990 electricity privatisation, we then transitioned into a commercial provider of technologies and services. And during that time, we developed and pioneered techniques such as TEV for measuring partial discharge, which is obviously a relevant theme here. And over time, those products evolved and were developed. In the mid-90s, we then later emerged as EA Technology as the business came. And fast forward 10 years, as products again continue to evolve, we had a staff buyout, which inspired a lot of new commercial offerings, which are now evolved into the positions we are more closer today. As by the end of the 2010s, we developed ourselves into leaders in electric network investment modelling and monitoring situations, and in particular, elements such as condition assessment, which is where our partial discharge activities lie, have evolved too with more data enablement and so on. So fast forward to very recently, we have an investment from Norwegian business Summa Equity, which a business which aligns itself very well with our values and our values of business and aspirations with respect to green technologies, etc. And that's allowed us now to evolve and move on to our next stages as a business and growth. So it's a period of growth and investment. And on the next slide, what I wanted to just as an overall catch-all, what we're about is creating safer, stronger, smarter networks, products and services really aimed and designed for owners, operators, or those responsible for the maintenance of electrical power networks. So essentially, it's about keeping the power safely on. It's about enabling us to manage our networks in a cost-effective way with monitoring type solutions to see the visibility of what's happening on our network. It's about preventing catastrophic failures, and that's where a lot of the PD sits with the condition assessment of our HV assets, and obviously the subsequent financial losses help us plan to avoid those. And with some of our software type solutions, we are able to help businesses provide them clarity with understanding the health of the asset base as a whole, looking at live predictions and looking at investment decisions, which helps the businesses on a wider case. And then, of course, always looking at developing products and looking at the leading edge of technology and bringing that to our client base, all with the intent of creating safer, stronger, smarter networks. We're based in the UK. Our headquarters is here in Capenhurst near Chester in the UK, but we have a global reach. We have with particular offices in the US, Australia, Singapore and China. So we have a global reach at this point in time, but headquarters over here in the UK. Before I pass back to Gareth, I just want to talk to you a little bit about the oil diagnostics. It's very much a complementary solution in terms of the condition assessment of our assets. So understanding what the health of our assets is with a view to kind of detecting early faults, improving lifetime and reducing downtimes, safety, regulatory compliance and cost savings. The capacity of the oil lab was recently around 40,000 samples a year. So we're looking to support people with global network operators, people with large scale industrial operations, the rail industry, renewables, service providers, looking at oil health in the electrical assets. So recently we went through a redevelopment on this, and now that has put us in a position where we've more than doubled the size of the lab and hitting over 80,000 samples a year. So that's relevant because it's all part of the wider condition assessment. And further investment in this area is we've enabled moving forward as data enablement, essentially working with a new cloud-based platform, our OLIMS client portal. It's a portal through which our clients, our customers can use a centralized repository for all of the oils data. We can use it for assisting the monitor of all of the assets health across their fleet. And also because of the management of that, it's allowed us to improve the data integrity because it's a digitalized process. You've seen the asset data through this platform, and it allows us to do sample reporting and also manage the whole oils diagnostic process. So that's coming very, very soon. But what I'll do now is, if I may, I'll pass back to Gareth, who will go through the webinar proper, and I will I'll catch up at the end. Thank you.
Thanks, Phil. So yeah, I think as Phil has used there, it's been a very exciting time at EA since we last spoke. We've heavily gone through an investment period, and you've seen the step change in the laboratory size there that we're now able to offer. In the PD world, we're in a changing space. There's this continued investment in our products is allowing us to keep that market-leading device, which is making your lives easy and really helping detect PD early on site. And that's something we thrive on doing and are really keen to keep pushing. As part of this webinar, I was going to introduce it's a third one in the series. There are two previous recordings available on YouTube via the links below. The first of those was a general introduction to PD, a bit of the why measure and how to measure and what techniques to use. And the second one was some case studies, some examples of what had been found throughout the year, giving a flavour of the types of issues you might find on your network. So if anyone hasn't watched those, they're available, and they give some background. As always, if you want further training, more detailed information on this, please get in touch. We offer a full range of training courses. Okay, on to today's content then. So the future of PD detection, quite a grand title for the webinar. The key bit is we're living in an evolving landscape. I think everyone on this call will be all too aware of the pressures facing electrical networks. There's massively increasing demand as we look to electrify, heat, etc. The cost of an outage it hasn't gone down recently. It keeps getting higher and higher. Getting hold of spares is challenging. So any replacement activity or repair activity is much harder than it used to be. The pressure on the network reduces the likelihood of redundancy. It's not easy to shift that load around following a failure, which is increasing the overall impact. And everyone seems to have a camera in their hand. And there's an article in the Telegraph only a couple of days ago with 10 substation failures over the last couple of weeks. Sort of almost frontline front page news. So people are recognising this, and there's reputation effect levels attached to that, regardless of what your main business might be. An outage due to electrical infrastructure failure is not good PR. And obviously, just to make all our lives easier, there's less of us to do this. There's less field engineers available, and there's less electrical engineers in general available per mile electrical network at the moment. And that's a challenge that isn't going to go away anytime soon. So living in that evolving landscape, and I think each of those key themes are going to be there in 2, 3, 4 years' time. What can we do from a product point of view? What's changing in the PD world? So the good news is there's quite a bit. There's a fairly rapid advancement in detection technology going on. So you look at our range itself, I'll come on in a minute. We've added lots of new sensor technologies over the last couple of years. We're really looking how to simplify the device for end use. And that's driven a little bit by the advance in electronics and data analysis and other bits in the background that allow that to happen. Everything's getting more connected. We can now have devices on site in your hands that allow people to be guided what to collect, to support the on-site activity, and share that data back centrally, where we've got our good old friend AI, which is obviously Front and centre now, AI is a very broad church, but fundamentally, that's allowing us to start to analyse the data more efficiently, and then push that knowledge back down into your hands on the device. So at the point of measurement, and you'll see some of the new features we're launching today, you'll be able to make that decision much simpler, and trying to build that confidence. The other bit that's really interesting is that PD's changing, going back to the left-hand side, and the demand on networks, the cost of replacement, the need for planning is increasing, and the need for investment cases to be backed up and underlined with data is absolutely key. So the ability of these devices out there now to move forward and basically collect that data in a coherent way, which can be passed across investment planning, is key. And that doesn't just come down to the device being able to record data, but everything from how you take the measurements in the same way, in the same place, so the measure is trendable, right through to then how that data is made available centrally to other systems and shared. And that's something which ourselves, we're along that full chain, including some of our products in the wider business, looking at the investment planning. So a challenging landscape for everyone, and PD, I think, still has a major safety role, but very much is forward-looking now. And the timeline that Phil talked through before, of how long we've been investing in this technology, it's gone from being an immature technology, a specialist technology, to being, in the early days, there's challenges, lots of noise sources, random number generators, a name that's been used many a time and 15, 20 years ago, through to now what's a really established and clear technology. So what are we doing then? So the first thing we're doing is trying to increase the coverage of these devices. So over the last 12, 18 months, if you take our core handheld device, so for those who don't know, the UltraTev Plus 2, this pictured front and centre, is our handheld device, and it's a PD platform. So built into the device is two measurement sensors. It's ultrasonic and TEV, so looking for internal discharge, originally in metal-clad switchgear. Over the years, we've added a number of sensors to this array, and we continue to build on this. And we're actually introducing a new one called the UltraVolt towards the end of the webinar, for those that stick around, pop with me for the next 20 minutes. But you can see that there's a whole array of sensors there, which aren't just aimed at metal-clad switchgear anymore. HFC lets us look down the cable, barrier sensors for GIS, whole other range. So we're collecting data, PD data, of a wider range of systems. So that now covers, this device is now capable on a range of devices, covering everything from your 11 kV ring main unit to the transformer cable box, right away through to underground cables, open switch yards, or 400 kV GIS assets. So the one device with the right sensor becomes really flexible. So just take an example for that. This is an example from a coal mine, actually. I think it's in Australia, this particular mine. Now, 66 kV coal mine, 66 arrestor, sorry, surge arrestor had an issue. Now, kind of doing the case study backwards here, I'm telling you where the issue is, but if you're going to go and survey this type of equipment, there's a couple of techniques available to you. There isn't one magic bullet that works everywhere. So first of all, for surface activity, we have ultrasonic. So our Ultra Dish accessory allows you to stand at a distance and pick up the surface activity, any surface tracking that may be going on those arrestors. You can still use TEV. So on the earth strap coming down from the arrestor, you'll have a good chance of picking up TEV signal, which you'll see on the next slide. Or a HFCT around the same point, same earth strap, will again give you some good information. On top of that, though, one of the strongest ways of measurement is using the UHF direction antenna. So this is moving from the sort of 3 to 80 megahertz range for where TEV is measured, and looking up to the gigahertz range instead. So much wider bandwidth there. That's allowing us to not look to basically look inside the insulator for any internal voids, any internal issues, while quite helpfully excluding some more of the corona type activity that you get in these locations. So 3 different techniques, and we're now looking at an outdoor asset, in 66 kV red line. So from TEV data, this is the sort of data, or was data, that was captured from that setup. So you can see here the blue boxes are actually one pair of events, probably a little bit weak, not directly obvious. You see the other data, you can see why it's a pair, but you certainly pick up the sort of events around 270 degrees and say, okay, there's something going on there. And there's another pair in the other in the green boxes, and it looks like it's possibly two sources, two phases of activity there ongoing. Looking further at the UHF, well, the way this is used is you to take a background sweep first. So you work out what the background UHF emissions are. There's always background noise in the area, mobile phones, etc. You then use a frequency scan on the device pointing towards the asset and see if there's any difference in energy level. If there is, it's quite Wikipedia would give you quite a broadband difference, then that's at the point where you know there's something going on. We'll investigate further. So you select a frequency range where there's a decent sized gap. So in this instance, somewhere in the 600 to 700 meg range. And then you go back to look at your phase plot. So you can see here, this is 660 meg, for instance. So now we'll look at a narrow band set of energy. So it'll be 2 or 3 megahertz either side. And we can see the phase plot is much clearer. And from this pattern, you can see, great, we've got an internal void. So this is typical, and this is how people have been using the product for the last 18 months, 2 years. We've had these UHF accessories out, possibly a bit longer. But they've also then been taking the next step of trying to record the data into a device that was set up for metal clad switchgear. And there's been a number, and many of you on the call I know have spoke to you about how the schemas you've coming up to mapping these things between and workarounds for this. But the device itself has never supported anything other than standard metal clad switchgear layout. So as you can see on the right hand side, we allow you to record the data against different components of that switchgear, and that's kind of like a flattened view of it. Works really effectively for metal clad switchgear, not so good when you map it to outdoor assets. So what have we done? Well, we've done the obvious thing. We've added a extra step up front where you can now cover all the different classifications of switchgear. And this brings quite a few advantages. So you can now map your data directly to a sensible place on a transformer, a cable box, etc. You can map an outdoor line, and you can start to record your data in a more consistent way, allowing you to do that planning at a later date. Because unless it's recorded consistently, you've got no chance of trending that information. So for those familiar with our current product, we already had a workflow on there. So this can either be heavily guided or just an ad hoc when you press record. It works on a principle of saving what asset you're at, what components, and then a sub-location. So I'm at panel 1, I've on the cable box, and my sub-location is L1, for argument's sake. We've now added a new layer up front, which is asset type. So from here, you may select that I am an outdoor compound. Your asset might not be line 1. You might then come down to disconnect switch and so on. So there's another layer there which just allows you to get that consistency. So on the device, this is what it looked like. It's very familiar. You select your asset or your asset type or class. And then as you go down a layer of detail, that will show you the relevant naming credentials, naming criteria. So for metal clad switchgear, that still goes to panel names, etc., and components. For outdoor switchyard, it'll go to line numbers, etc., and the components and sublocations in there. And you can store, for instance, an outdoor yard component details for each component manufacturer type, which will obviously be different to most cases. The other advantage is this all links you to our cloud platform. So you can now on the cloud platform create workflows or substations that have multiple assets. And you can have within one survey where traditionally, if you had, say, 2 boards or, say, a ring main unit and a transformer, you'd save that normally as 2 surveys. That can all now be stored as one survey. So you're simplifying the activity on site for people. Bear in mind, the reason for doing all this is all about making that data management easier going forward. There's a lot of data which people aren't recording, and we've learned from, we can show you a bit later in the presentation, where the width of activity and the phase plots are so important in trending over time, not just the amplitude or the pulse per cycle. And being able to trend it by clicking back on the exact same measurement point 6 months ago is really helpful in planning. So that was the first topic for today. And the first sort of step change we're making towards that data future. The second bit, I mentioned AI, everyone's favourite topic. So we've always had on the device, especially for the most critical measurements, ultrasonic, which, to be fair, in typical activity, probably 70% plus of what we find is ultrasonic led. We've always had classifications on their algorithms that tell the user directly on the device whether that is likely to be PD or not, with some degree, a very high degree of certainty actually in the ultrasonic world. And that's always been slightly more challenging in the TEV world. Now, what we've tried to do and what we have done is collect a lot of data over the last 18 months to be able to really try and improve that with the extra resolution we have. So over the last 18 months, we've collected somewhere in the region of about 30,000 TEV samples, so one or two. We've then gone through and manually classified those samples. And by that, I mean, we've looked at the pattern, we've looked at the waveforms behind them, we've looked at all the other information we have on our site and decided that looks like or is actually PD or not. Yeah, all sorts of different noise sources in substations and from TEV readings. And it isn't always that obvious to tell. So but a lot of time going into classifying them. We've then trained multiple times an AI algorithm. And this AI algorithm has allowed us basically to get to a recognition accuracy in the test set, so where you split the samples between training and testing, to about 97%. It's not perfect, but 97% is a damn sight better than majority of end users and myself consistently on site. So the algorithm will do this without you thinking, without you having to go through extra training. It'll identify that data and it'll give you its recommendation. And that's a massive usability step forward for people on site. It's just another tool, it's another support tool. And it's something which will continuously improve now. So we will retrain this and keep on improving the AI as a sample base increases. But already the first cut of it you'll see released in the software next couple of days will allow you to get immediate feedback on site and simplify that collection. So just for clarity, all the things I'm showing here are going to be available on a firmware update for the device. I'll touch on that for existing users a little bit later in the conversation. And it's all freely available as well as always. So I think the UltraTEV Plus 2 is probably the most updated and feature-rich device out there that we've always supported and will continue to support adding features to. So on the other side of the spectrum, so we've talked about making it easy for the guys on site. There's a long list of names I recognise on this call that are engineers and like the detail. So the other side of what we've done is increase what the UltraTEV Plus 2 can capture. So the UltraTEV Plus 2 has always captured waveform information, and we've also captured phase plots. We've changed that now to capture a lot more information around the waveform activity and to calculate continuously some more metrics around the shape of the waveforms and how they behave. We've introduced some of that in the previous webinars, and we're taking that a level further now by adding in TF mapping, which is time frequency mapping. Many of you will be aware of this technique from motor testing and from online systems, but in the handheld world, this is, as far as I'm aware, unique. And the advantage of it is it's a post-processing event, which allows you to capture all your data up front. You're not throwing anything away at the point of capture. But you can then analyze and remove different noise sources or even separate different PD sources based on waveform shape. I'm just going to talk you through an example of that on the next slide. But this is available on the device, so it's on the SD card of the device. You run it on your local laptop. And it's a really specialized and advanced sort of method of separating out that noise. It is, we've got two sides of this for making the device really easy to use on site, but where you do have those difficult cases and the very small 1% of cases, this is another tool in your armory that you can use. So I'll just press play on this short video. Okay. So you can see just changing the top right-hand corner here, there's a number of waveforms that we capture on the device. So every 10-second capture now, we capture 500 sample waveforms for you. And they're to give a flavour of the waveforms across the capture. Now, as you'll see as this goes through, those waveforms are all different shapes and sizes. And what we're trying to do then is group them by similar properties. So by selecting a part of the chart in the left-hand corner, it will show you waveforms that look similar. They've got similar properties on the chart below. So if we just take a look at that, selecting these waveforms here, all of these waveforms have got a similar shape. Start with a pulse and another pulse in fairly quick succession. If we take another outline group at the top, all these waveforms are noise. They're very oscillatory, relatively low level. And they've been pulled out and separated. You can see them spread across the phase part at the bottom, but also a different point on the TF map. You can drive this backwards, so you can select the part where you know is PD, and it'll show you where that is in the time frequency domain. You can see those waveforms there. And then we could say, okay, well, what is else around that? So we know they are PD and they look sensible. Is there anything else in that area that's also PD? So you can have a slightly wider view of the TF map. We pull in the two areas of partial discharge on this point. This technique is particularly helpful if you have like inverter noise or on turbines, etc., and allow you to separate the background noise quite efficiently from the PD. So it's as much as we're trying to automate it and make it as simple as possible for the end user. Underlying there are techniques like this that you can use if you wish to look into more detail and take the more challenging cases. So that's another feature on this release. So I mentioned this release a few times. This is version 5 of our software. If you wish to receive it, you just log onto your device, sign up for Substation 360. That's our centralized platform. It's a free service to sign up to get the initial access. And you can from there download directly to your device over the Wi-Fi this update. Alternatively, if you can't connect that way for any reason, please just get in touch with ourselves from the QR code below, and obviously we can support you there. And if you haven't yet got a device, definitely get in touch via the barcode, and we'll come and demonstrate the advantages to you. Okay, on something that I've mentioned at the beginning of the meeting now. So there's a new accessory coming out for the UltraTEV Plus 2, which is going to be a bit of a step change in repeatability. So going back to that theme of data at the beginning and able to make repeatable and trending activity. The UltraBolt is our latest accessory. This basically takes ultrasonics, which we currently measure on metal clad switchgear using airborne microphones, so looking for acoustic emissions. So a photograph here of Tom from our Australian office. He's scanning around the gaps in the metalwork, so where the metalwork joins together, and that works. It's quite effective. We can see from that how there is the small air gap will allow the energy from the PD to escape, and if you can detect it quite efficiently, but it is very localized. It's also very hard to repeat. So if I ask Tom to pose for the same picture again, he might get the smile and the look, but I doubt he'd stand in exactly the same position with the same distance to the sensor, and that changes your repeatability. The alternative we have, obviously, for boxes where you haven't got as many air gaps, is the contact probe. So we have a device that can go on the outside surface of the device, but again, that works when there's a single skin and there's no air gap really, so it's a limited application, but again, another useful tool. So what we're moving towards, really simple, a bolt. So you've got plenty of bolts in your switchgear. This one had a replace a bolt or an additional location. I'll say the user caveats. We're not the switchgear designers. This should be done in line with their safety regulations, your safety regulations, but it is quite normal to have more past switchgear with bolts missing. So using one of those holes that we've often used to try and take TEV readings and actually putting a bolt back in gives us a sensor, gives us a permanently mounted sensor into the switchgear, which we can magnetically couple to. So this sensor doesn't protrude any further than the bolt into the switchgear. It has a sensor built into the center of the bolt, effectively, hollowed out bolt if you like. and that allows us to take ultrasonic readings from inside the cable box in this instance. So the process looks straightforward like this. The bolt is retrofitted fitted either in an outage or otherwise. You then magnetically clamp the reader to the bolt, which just drops on top, and that straight away is recognised. You've made that connection in the UltraTev Plus, and the Plus will start its capture and allow you to see the classification, so whether it's PD or not. It's giving you a really repeatable measurement location. It's allowing you to trend ultrasonics probably for the first time in a repeatable manner. And again, it's a level of familiarity and possibly, as I say, training less than what's previously been required. That location is consistent. You're dropping it on. It's easy to take that repeatable measurement. And with the back-end systems, you can then do the analysis locally, also remotely, if you wish. So to me, this is there's no one-size-fits-all in the PD world, but this is yet another tool in the box. It's one we've had a lot of interest in the early days, but we are at the stage of looking at beta trials. And if you are interested in this, please get in touch. We're looking for a couple more people to sign up for beta trials. If you're unlucky enough not to get selected for that, then by registering your interest, as soon as this product's finalised, we'll come and demonstrate it to you and make sure that you're given the early information. So please do get in touch. So from myself, that's pretty much what I wanted to cover today. Just give you a feel that things are moving forward. Data's a big part. The day-to-day conversations with both industrial and D&O customers are focused on the data and the repeatability of that. And I'm just going to pop across one last slide from Phil, and then we'll come on to Q&A.
Well, thank you, Gareth. That was really good. I just wanted to take the opportunity to, some of you may be aware of this event or not. We run our Industrial Forum event this year. We have a theme of keeping electrical switchgear safe. It is a free event, which is now, you're able to register for free and attend. It is placed on the October 14th at Chester Racecourse. It's an opportunity to network and mingle with your industry peers, asset managers, engineering managers, technicians, and across the base. And we can talk. I'm sure you'll have opportunity to see some of these products in person, and also have opportunity to share best practices with a series of presentations run, and probably some demos and other activities. So we'd love to see some of you come join us. We're also having opportunities for exhibits as well, if you wish to come and exhibit at the event, tabletop exhibits, and there are sponsorship opportunities. There is a QR code again if you want more information, or you can reach out to the sales@eatechnology.com as well. But I just wanted to make you aware of that event because it's a really good event, usually gets very good feedback, and we'd love to see you come join us.
Okay, thanks, Phil. Okay, I've got a couple of questions. I've got a slide. So a couple of questions come through in the chat I'm going to answer. I've seen a couple of hands go up. Unfortunately, we can't add audio with this call. So if you have got a question, can you please just drop that into the chat, and we'll pick that up now. So the first one, I like, can I join the Autoport trial? Absolutely. We'll come back to you on that one. The second question on there is, let's understand this. Okay, so around the +2 and use on the different asset groups. So if you are doing a single survey or going out to site survey, yes, you can structure it so that you can, before you go to site, you can define what measurements to take. And in one sort of guided survey, that can include a piece of switchgear, a transformer, outdoor section line, if you wish, all in the same file. So all of those results can be collected in one file and centralised as one recording, which is a change to previous. Yes. Next question around the applicability of the software. So that is applicable to all of the +2 devices are out there. So if you've got a +2 device, we can update it. It is over the air only on this level at the moment, though. So we've supported the SD card approach for a while. I think that's more challenging for people with IT access, etc. So we are ideally moving towards over the air, but do get in touch if that's a challenge for yourself. And think that's it. If you've got any more questions, you can see your side, Cal. That's all I can see there. No, okay, please. Okay, so how do you see the role of high frequency sensors evolving, basically for GIS and cables, etc.? They've been established for a while. They're not new, these techniques. The cost of them's been challenging. So the data processing that's required has been challenging around that. And I think that's what's going to evolve more than anything else. The ability of handheld devices like this, example, come 100 megahertz, to be able to use those sensors. And then the nice bit about being able to use the handheld devices is you can take more measurements at less cost. The database builds up and we'll be able to improve on the analysis of what we've been doing previously. There's also a move to building sensors inside gear a lot more now. Some of those are UHF. So in new switch gear, for instance, I won't mention the manufacturer's name, actually thinking about it, but there are manufacturers out there which will build UHF sensors into the switch gear now on medium voltage as standard. Any further questions?
I have one more coming about the potential to add a camera to the UTP2. Might you feel that would be any use?
Okay, so I had a question about the potential to add a camera to the UTP2, and this is one that comes up quite regularly. So the Plus 2 itself does not have a camera feature internal. Cameras evolve very quickly, and most people have a smartphone in their hands, which has a perfectly good camera on there and updated very often. So what you'll find on the Plus 2 is there's a hotspot built into it, and you can connect direct to the hotspot, and you can add images, files, etc., videos directly to your surveys. So if you have your phone on site, you can take a photograph of and associate that very quickly with a reading and a panel. So that information is there and available to you.
Just a couple more comments we'll just cover quickly. Does the bolt also serve as a mechanical fastener with an impact type test?
Okay, just had a question about, does the bolt serve as a mechanical fastener, and does it into impact type test? So the bolt itself has got mechanical strength to the equivalent size bolt, but it's about 50% of that. So it isn't an equivalent mechanical fastener. It isn't obviously installed that type test with your manufacturers, so it would affect that, and it'd be under consideration where you use this. And obviously some switch gears are created, and you have to they are creating, and that side of thing is stuff we all continue to look into. But at this stage, you're balancing that against the safety of not having a PD failure and being able to see inside the unit. So it's a local decision.
Okay. Just a few more coming in around the UltraBolt mainly. Would the UltraBolt be able to become a permanent solution that we can monitor live on site?
So would the UltraBolt be able to become a permanent solution we can monitor live on site? Absolutely. So Watch This Space, basically, we'll be moving that onto our monitoring platform going forward. Initially, we are starting off in the handheld space.
Just for one more.
Okay.
Is the UltraBolt suitable for SF6 application?
So the final question is the UltraBolt suitable for SF6 applications? So obviously SF6 gear as a whole, so anything with SF6 chamber inside, no, it's not going to be. We can't access the inside that chamber, obviously the gas tight chamber. But a lot of SF6 switch gear has cable terminations, cable boxes, etc., which are air insulated. Yes, for that particular part of the switch gear, it is. But no, not direct into the SF6 chamber.
Okay, a few more, but I think we'll call it that.
Okay, brilliant. Well, if any other questions we haven't answered at all, we will follow up directly after the webinar. The recording is available and will be available by email and be on YouTube for you later on if you wish to review any bits back again. And please reach out to ourselves, so either Phil or myself or the wider sales or product support team at EA if we can help in any way with your PD problems, or wider asset management. There's a full team here at EA that cover the full spectrum of asset management and would love to speak to you. Thank you very much for your time.
Thank you.